Hello everybody, today we're going to be going over a ratios problem at the IB Math Studies level. In the problem they tell us that the size of a computer screen is the length of its diagonal, okay? And that Susana buys a rectangular computer screen with the size 68 centimeters, which is the line going diagonally, a height of y and a width of x, okay? And thankfully they give us the graph. So part A asks us to use this information to write down an equation involving x and y. So first things first, this line right here is equal to this line, and this line, the height, is equal to this line, okay? The reason I know that is because this is a rectangular computer screen, and this is a property of the rectangles, okay? Also, the right angle on the bottom right is the same on the right angle on the top left, okay? So, immediately after looking at this right angle, one should think, when you're facing a triangle with a right angle, you should immediately think of using the Pythagoras theorem, okay? The Pythagoras theorem, okay, that's not a good drawing, but this is right angle, says that if this is A and this is B and this is C, we're going to have that the sides squared added together is going to be equal to the hypotenuse, which is a fancy way to say the long side, squared. Okay, so A squared plus B squared equals C squared. This is Pythagoras. So this is what should always come to mind when looking at a right angle. So for part A, the equation we can write is saying x squared plus y squared equals 68 squared. Okay, since 68 is the diagonal, this is going to be the hypotenuse, and we just replace the values. Now they tell us that the ratio between the height and the width of the screen is 3 to 4. Okay, now for part B, we need to use this ratio to write down y in terms of x. One way to look at this is by saying that the ratio of height to width is equal to the ratio of 3 to 4. Okay, this is pretty logical so far. And what I suggest is that after you set it up this way, you get in your brain that this symbol for ratio can also be written as slash or divide. Okay, these are three different ways in which you can express the same thing. Okay, so plugging that in, we can have that the height divided by the width is equal to 3 over 4. Okay, and now we replace height for y and width for x. We have y over x equals 3 over 4. Okay, the next step when you have something like this is that you can cross multiply. In other words, you multiply y times 4 and x times 3. You can always do this when you have two fractions like this, and you end up with 4y being equal to 3x, right? Now, since we need to use this ratio to write down y in terms of x, this implies that we want to have a y equals something. Okay, so we want to get y alone. We divide by 4 on both sides. We end up with y equals 3 over 4x. That is the answer for part B. Okay, the common mistake here is that when setting up the problem, you might say like, okay, so 3 height will equal 4 width, right? And this sounds logical, and then you plug it in, and you end up with 3y equals 4x. You do the same process, but you end up with y being equal to 4 over 3x, right? Which is different to what we got using the other method, right? The reason this doesn't work is because if you work it backwards, right? From this step, if I work it backwards to try to reach this, I'm going to end up with the following. If I divide by width on both sides, cancels out here, sorry. We end up with 3 height divided by width equals 4. I divide by 3 on both sides. And we end up with height divided by width equals 4 over 3. Okay? And if we use the ratio thingy, it ends up like this. Which is actually very different to what we had in part B. Okay? This explanation here is just to show that it's important that you set up the problem in this manner. Okay? Because even though saying that 3 height is equal to 4 width sounds like a logical way to state it, the math behind it doesn't work out the same. Okay? So you always want to set it up in this manner in order to avoid that mistake. Okay, and finally for part C, they ask us to find the value of x and y. Now, much like any other problem and in IB in general, for part C, you probably want to use information you got from parts A and B. Okay? So, in part A, we have an expression that has two variables, x and y. And in part B, we have a y equals something, right? So we can substitute the y equals something into the first formula. The reason for this is because we end up with only one variable in the problem. Okay? It's important that when you plug it in, when you plug anything in, you want it to be in parentheses always. This way, you don't mess up the square, the exponent of 2 that we're supposed to be putting. Okay? So, working this out a little bit, we end up with x squared plus 9 squared divided by, working this out a little bit, we end up with x squared plus 9 divided by 16, right, because 3 squared, 3 times 3, 4 times 4, and x squared equals 68 squared. Okay, combining these two like terms, we have 16 over 16 x squared plus 9 over 16 x squared equals 68 squared. Here I just multiplied the top and the bottom by 16. Okay, so they have a common denominator and I can add the fractions. Fractions, for adding up subtracting, they have to have the same denominator, and for multiplying, that doesn't matter. So that is why in this scenario I had to convert it into this. Okay, this ends up being 25 over 16 x squared equals 68 squared. Okay, and this whole thing I'm going to multiply by 16 on both sides and divide by 25. That way here it cancels out on the left. On the right, I'm going to end up with 68 squared times 16 divided by 25. Okay. Then I want to do the square root on both sides as well. Because if I do the square root while it's squared as well, these two are going to cancel out. So whatever the square root of this is the answer. Okay. And the answer is x equals 54.4. Okay, and now that we have this information, we still need to get the value of y. There's many ways to do this, and what I suggest is just plugging it into the formula of a. I can plug it in two places. I can plug it in here, or I can plug it in here. Same thing, really. I'm going to go for the formula in part A, but they both give the same answer. So 54.4 whole thing squared. I plug in with parentheses always, plus y squared equals 68 squared, right? I want to get y alone, and since it is being added, the 54.4, I need to subtract both sides by 54.4 squared. We end up with y squared equals 68 squared minus 54.4 squared. We do the square root on both sides. We end up with y being equal to whatever this is on the calculator. Okay? And that is, we end up with y being equal to 40.8. And it's important, because it's part of the mark scheme, that you always put the units in these problems. Okay? So here we're going to put centimeters. And that is the problem. I hope it helped.